Hello everyone. So we can start the session, right? Rajeev sir. Hello sir, can you hear me? Hello guys, so we can start the session. Good evening everyone and a very warm welcome to all of you. Impulse is a 2-week long mentoring program where you are introduced to the basics of programming in Python, ML, CV, DSP and MATLAB. Topping it off with a hackathon where the top performers will be awarded cash prizes from a prize pool of $150. And today we have Dr. Rajan with us for this session on Introduction to MATLAB. Dr. Rajeev received his BTech in Electronics and Communication from College of Engineering, Adur, his MTech in Applied Electronics and Instrumentation from College of Engineering, Trivandrum, and PhD from the Department of Computer Science and Engineering, IIT Madras. He has many national and international publications in journals and conferences, and his research interests include speech and music signal processing and image processing. On behalf of everyone here, I welcome you, sir, to the session. And for the kind attention of the participants, please note that the attendance is mandatory for your certificate, and use your full names in Zoom so that we can take your attendance. And so once again, a hearty welcome to every one of you. Over to you, sir.
Okay, thank you. Thank you. Am I audible? Audible or no? Am I audible?
Sir, we can't hear you, I think.
Is any problem? Just a minute. Not audible?
Yes, sir, we can hear you. Yeah, we can hear you.
Audible or no? Audible or no? Am I audible? Some range issues may be there. That's why. Am I audible?
Yes, sir, you're audible.
Okay, okay, yeah. Okay.
Yes, sir, we can hear you.
Okay. Okay, thank you for inviting me for this session. So due to the bandwidth limitation, so I shall keep my video off short for a while. And how many of you have experience in MATLAB? Can you just share your previous experience? Anyone new to this MATLAB? Or I think around 72 participants in this session. So how many of you have experienced MATLAB earlier, experiments with MATLAB? Can you just anyone new to MATLAB? Anyone new to MATLAB? Yes, Akshay is new. Anyone else? Yes, yes, yes. Okay, okay. Yeah. Because I should concentrate on the different parts. That's why I'm asking this question initially itself. Because many of you might have done a lot of experiments in MATLAB. Someone may be new. Okay. So you can see this screen now.
Yes, sir. Yes, we can see your screen, sir.
Yeah. So my today's session is divided into three to four subtopics. First, I will explain about some basics. Just a minute. Then editor window programming. Then we will discuss about fuzzy logic. Third one, Simulink. So my talk is divided into these four subsessions. First, we will go through basics. Then editor window programming. Then, of course, fuzzy logic. Just a minute. So let's start with some basics operation MATLAB. So MATLAB means its name comes from two terms. One is metrics and second one is laboratory. Okay, metrics and laboratory. That's why it is known as MATLAB. Okay, metrics and laboratory. Metrics and laboratory. It is very powerful tool. It's a very powerful tool. And the latest version is 2021A. Okay. So every year they will release two versions. Most probably one in March or April. Second one is in October. So we can expect 2021B by coming October. Okay. So MATLAB, the recent version is 2021A. Then MATLAB is developed by MathWorks, as you know. It is developed by the premier MathWorks, and it allows matrix manipulations. Okay, matrix manipulations, plotting of functions and data, implementation of various algorithms, creation of user interfaces, interfacing with programs written in other languages. Okay. In addition, it has numerous built-in functions. It has numerous built-in commands and math functions. Actually, that help you in mathematical calculations generating plots and performing numerical methods. Okay. So due to very short span of time, so it is difficult to cover all portions. So that's why I have covered just basics for new people and the new and two toolboxes, fuzzy logic and simulate. How will you uh, design a fuzzy logic controller using MATLAB? We will see. And second one is how will you simulate a mathematical model in lab? Okay, so we will discuss these two models. I think these two will be helpful for those who have already experimented MATLAB, and this will be helpful for mainly helpful for the new people. So that's why I divided the talk like this. So actually nowadays MATLAB is used in every facet of computational mathematics, even in electrical engineering, even electronics engineering, or computer science engineers, even financial signal processing, data analytics, and even in genetic engineering. Okay, so many people nowadays use this MATLAB as a powerful engineering tool, and it can it can easily do many mathematical calculations. Most commonly, for example, dealing with metrics and arrays, two-dimensional and three-dimensional plotting, linear algebra, nonlinear functions, statistics, data analysis, calculus, integration, transforms, curve fitting. There are various operations that can be performed very easily using MATLAB. Okay, so let's start with the basics of MATLAB. So first, let's start with the basics of the MATLAB. So first, do you have MATLAB with you now? System undo ellavarkum? System aayittanno irikkunnathu adho just simply sitting for a talk? What is your response? You can use your chat box to communicate me. Okay. So what is the current status? Do you have a system with you, or what's the situation now? System undo ellavarkum? Yes, okay. Just you can open your MATLAB. Just open your MATLAB and I feel you might have opened your MATLAB. Okay, so this one is called, so you will see certain windows there. Okay, you will see certain windows there. This one is command window. Okay, this one is command window. This is command window. This is editor window. This is workspace. This one is command history. This one gives information about your folder. Okay, where are you now? Your current folder. Okay, these are the, you will see many operations in the top title bar. When you place your cursor and when you click some of the functions in the title bar, many sub functions will be pop up. Okay, so the left side you will see the current folder, and the main window is the editor window, and the command window, and workspace, and command history. So editor window means you can write your programs there. For example, multiple lines. There are multiple lines. Most probably, when you write a code, definitely there will be more number of lines. So to systematically evaluate every line, what happens, it is better to write coding editor window. So that's the editor window. So you can see in the top. So there are many programs I have used as part of my experiments. So these are the codes I have used in my experiments. So this will be listed here, and you can change the view. You can change the view by you can split left or right, or so there are many options to change your layout. Okay, so I have used as none, and in some cases you can include command history. In another case you can no need to use command history. Depends upon your choice. Okay, so command history means the previous commands. For the previous commands will be here. So just to double click on the command. For example, this is a previous command I used. When I double click, it will be displayed in the command window. So this is command window. This is editor window. When you write a program in editor window, directly go to editor. There will be one symbol run. Okay, this is the symbol run. When you just click this window, so that code will be in running condition. You can see the output. So I think it may take some time, I think. So, also, this was a program to run to know the variation of accuracy when you change number of layers in a convolutional neural network. So it was a program I used in my experiment. So I have values. I entered those values, and it's a plot showing the variation of accuracy with number of layers. Okay, so I have just used this command from. I haven't typed anything on the command window. I just double clicked on a previous command I used from the command history. Okay, command history use that's the use of command history. And next one is workspace. In workspace, you are using many variables in your program. So what are the values that is stored in these variables when you run a program? When you double click, so you can see this is it's like an array. 1, 2, 3, 4, 5, 6, 7. Okay, these are the numbers stored in the variable X. Okay, these are the variables I stored in P. So when you double click on the workspace in a particular variable, you can see the values stored in those arrays. It is very useful to examine the values in any variable when you do an experiment. Okay, when you do an experiment. So it's very useful. Workspace is very useful to just analyze the content in each variable, because that is the application of workspace. And of course, in command window, that means when you write a program in editor window, you have to save it in appropriate name. You have to save it in appropriate name. Then just type that name in command window. Okay, then for example, just a minute. This is called capsmooth.m. It's a code written for capsule smoothing. It's like a function. I have written like a function. So when you just type capsmooth, it won't work because it is called by another function. Otherwise, you have to pass these variables here: signal, smoothing, fall-off, SLN. When you pass these variables and just type this function name here, it will be in running condition. So first you write a program, save it in a particular name, and for example, with an extension .m, and type that name in command window. Otherwise, you can simply just use this, just click this button, run, it will run. Otherwise, just type that name of the program in command window. It's very careful that you should not use any names of built-in commands. For example, add. Some commands, they already in the MATLAB libraries, they might have used some built-in commands. So when you try to save any of your program with the same command name, it will show error. Okay, any built-in command name, you should not use any built-in command names in your when you rename a code, when you rename a program. Don't use any built-in command names. It's very important. Okay. Usually we have seen such errors when we carry out our labs. So I have observed many times. So don't use any of the built-in command name, okay, for your private programs. Okay, that's very important thing. I think got familiarized with the window. Okay, window command window. This is the editor window. This is command window. And right side the top is workspace. Right side bottom is command history. But you can change alignment, no? Whenever you want, you can change alignment. In my system, I used such an alignment. Okay, you can, instead of this, you can use command history in the bottom. It's up to you. You can change the layout. You can change the layout in the view. There's a one view option is there. You can change the layout. Okay. This is just, that means you can give your choices here. Okay, to visualize the MATLAB windows. Okay. So I have discussed about folders. I have discussed about this editor window, it's command window, workspace, and command history. Okay. Now let's start some programming exercises. So it's very interesting that MATLAB always take a variable as matrix. That's why it is known as matrix laboratory. So whenever you define a variable, MATLAB takes as an array. Okay, it's taken matrix, and it uses many matrix operations, metric manipulations as per your code. Okay, it's very interesting that the matrix, that is MATLAB assumes every variables as a matrix. Okay, let's start. I define a variable m. So you can also start. So just 1, 2, 3, and 4, 5, 6, 7, 8, 9. So I define a matrix. First, let's go to the matrix operations. Then let's go for calculus and polynomials. Okay, the related things. So I define a matrix. When you just use a semicolon, it will be stored as. So now when you type m, you can see that the elements of the matrix 1, 2, 3, 4, 5, 6, 7, 8. At the same time, it will be displayed in workspace. In the workspace, that variable will be there. The other variables I used the previous experiments. And now I defined a matrix m. 1, 2, 3, 4, 5, 6, 7, 8. So instead of if I use another thing is you can use up arrow. In up arrow to just revisit the previous commands. You can use up arrows. When you use up arrows in your system, you can see the previous commands. Okay. So this I define a matrix m. If instead of semicolon, if I type like this, when I click enter, then also the value will be there. But you can avoid this pop-up by simply adding the semicolon at the end of that matrix bracket. Okay. Now, so M is like this. If the next thing is the matrix index start from 1. Okay, there is no 0 in the matrix MATLAB index operations. The index is taken as 1. Okay, so that means the first element 1 means the first row, first column. Okay, so the element M11. Just a minute. Okay, M11 first element. M21. So so you can access every element of the matrix like this. Okay, M32, M32, that means third row, second column. Element is 8. Okay, so I define matrix. If you can easily replace any of the elements by assigning some values. That means I assigned 10 to the that means third row, second element, second column. So now your M will be, just a minute. Okay, so that element is replaced with number 10. So you can easily manipulate any of the element in the matrix, even if you can replace with the you can replace the entire row or column also like this. For example, M of see that when you type this, you see just the second row completely disappears. Okay, so you can remove row, you can add row, otherwise you can replace any of the elements in the matrix using a simple basic commands. Okay, basic operations. So it's very important that you have to keep it in mind. That is, so that means the basic index is 1. Okay, 1 1 1 2 1 3 2 1 2 2 2 2 3. That's very important. Okay, now Now let's do some basic operations. I define two variables. A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 7, 8, 9. I define one matrix. I define another matrix. 7, 5, 6, 2, 0, 8, 7, 5, 7, 1. I define two matrix. Let's do some operations. A plus B, adding some matrix A plus B. So I added two matrix. So that means when you add matrix, keep it in mind the basic rules, because number of rows, number of columns, it should match. And A minus B, D is equal to A minus B. So you can see the answers of C. You can see answer of D. Okay, A plus B, A minus B. Now, what is A by B? So you can multiply A into B, A into B. This is matrix multiplication. Matrix multiplication. Now, instead of that, I use like this. What happens? It is element-wise multiplication. So you see the difference? A into B. It is matrix multiplication. If you want to multiply the corresponding elements, okay, that means in this case, A, the first element is 1, it will multiply with the first element of B. Okay, that means 1 will be multiplied with 7, 2 will be multiplied with 5, 3 will be multiplied with 6, 4 will be multiplied with 2, 5 will be multiplied with 0, 6 by multiply with 8. So element wise, that is A dot. You can see the difference, A dot. Here, just you are using multiplicative sign. Okay. Now, you can divide A by B. A by B. A by B. A by B. So division, elements will be divided. What happens if you use A? What is the difference between A left division and right division? Can you say the difference between left division and right division? Anyone of you? Can you just say what is the difference between these two? What happens? I have got answers for both. What is the difference between these two? ആർക്കെങ്കിലും പറയാമോ? A left division by B, A right division by B. Can you just, anyone of you? Those have already used MATLAB. Can you share the answers for that? Yes, correct. Inverse. Srigesh replied that. It's not direct inverse, but A into inverse of B. That's the answer. Okay. A into inverse of B. A into inverse of B. So keep it in mind that A into inverse of B. That's the meaning of this. So inverse of A, inverse of A, inverse of A, determinant of A. Okay, these are all the basic commands. Okay, determinant of A, inverse of A. Adella orthola basic commands unda. Transpose, A transpose. Transpose, you can write like this also. Transpose of A. Both are correct. Okay, can use a just an apostrophe, otherwise you can use transpose, word transpose, determinant, inverse. So these are the basic commands. Then A plus B, A minus B, transpose A by B, A level right division by B. Concatenation is also possible. That is, A, just define a new matrix E is equal to A. I have already defined A and B. Let's see what happens. And if I write like this, what happens? See the difference between this concatenation row wise and column wise. When you use a semicolon, it will be concatenated at the end of the end of the first matrix. If it is if there is 3 row, then it will be added in the end of the third row. Okay, you see the difference between these two. A semicolon, and so actually you're using matrix operation here. Okay, so you can easily visualize all the values here. The right side, the workspace, you can visualize all the values here. E you can see, DF you can see, D you can see, C you can see, B you can see. Yes. Okay. So concatenation, matrix multiplication, determinant inverse. Okay. So remaining of you can use this help. Okay. Help, documentation. You can also type documentation, help, documentation, MATLAB, mathematics, elementary max. Okay, you can try all this commands. Okay, path manasilayallo, that means help. So once again I will try. So it is, we may not be able to cover all the commands. That is, go to help, documentation, various toolboxes. Just click on the basic MATLAB and go to the mathematics tab, elementary max, arithmetic, trigonometry, exponents, complex numbers, discrete max, polynomials, special functions, etc. When you click there, basic arithmetic, modular division, customary. So you can see the commands here. Okay, commands and its syntaxes. Okay, so that's the thing. Trigonometry, elementary math itself, arithmetic, trigonometry, exponents, help. Okay. So if you want to get syntax of anything, you can simply type help ditch. It will display the syntax for any of the commands. You know the command name, but you don't know the syntax of the usage. Simply type help and command. In some cases, you may not be able to know the command itself. Then it's look for some command is there. Got this, just a minute. Just a minute. Command is so anyone, can you just try a few experiments there in trigonometry, or can you all of you, can you please try some of the operations? Just go to this math library. Go to the math library and help, documentation, MATLAB, mathematics. Eigenvalues. You have a matrix A. Please type eigen of A, eigen of A. Eigenvalues, eigen of A. At least try some of the commands here. Elementary max, trigonometric, sines and cosines, sine d, sine pi, arc sine, sine inverse. Okay, sine inverse is a sine. And logarithmic functions, log 10, log 2, log 10, log, exponential. Okay. You can use some look for command to, if you know at least just some keywords in the code. You can use some look command to just get the list of the commands which uses that particular keyword. Okay, so on a look for command, you can use that command to because you don't know the exact name of the command. Okay, exact name of the command. You want to know Fourier transform, otherwise transforms. You can easily use help. Some look command is there, and we can use it to verify some look for or look. I'm not convinced. I don't know exact name convention. I used it earlier. I used it. You can use that word. You can search it in net. You will see. Okay, just search in Google. You'll get that particular keyword. That means you want to know the list of commands, list of the commands, and which uses a particular keyword. Then you can easily identify. Oh, this is this code I am looking for. So this operation I'm looking for. Okay, you can use. So you can search it later. Okay, now plotting. Let's go for some plotting graphics. Okay, so x is equal to some 1 to 10. That means I defined a variable. So when I write this x 1 2 3 4 5 6 7 8 9, I define an independent variable, and define a new variable x dot square. X square, I want to see x square. Then plot x comma y. Plot x comma y. Plot x comma y, it will be like this. Okay, but actually I entered like discrete values. So I got a continuous curve. So you can use a stem plot. You can use stem. Then you will get like this. Stem. Got the difference between plot, stem? Another interesting thing is, if you want to draw multiple diagrams, you can use subplot command. Subplot. That means, so you want to draw four figures. That is intermediate results you got when you do an experiment. So you want to draw all these four figures in a single window. So for example, this is the screen. I divide into four regions. This is first region, this is second region, this is third region, this is fourth region. Figure 1 should be here, figure 2 should be here, figure 3 should be here, figure 4 should be here. So subplot 2, 2 means I divided this entire region into 2 rows and 2 columns. And first figure, that means so when I use subplot 2 to 1 means my interested region is here. So I can write plot x comma y. This will be plotted here. Then if I use subplot, so this is to specify a particular area in the screen. Okay, area in the, for example, 2, 2, 2. So I use plot x comma y. So it will be drawn here. So 2 rows and 2 columns, second position here, third position here, and fourth position here. Okay, so subplot means you're dividing a space and you specify a particular space for plotting a variable. Okay, so subplot, that's a use of subplot. So then subplot 3, 1, that means 3 rows and 1 columns. It will be like this, 3 rows and 1 columns. So this region is subplot 3, 1, 1. This is subplot 3, 1, 2. This is subplot 3, 1, 3. Okay, these are the different regions. This is one region. This is another region. This is another region. So this means 3, 1, 1. This means 3, 1, 2. This is 3, 1, 3. Okay, so here I divided the entire screen into 3 rows and 1 columns. Here I divided the entire screen into 2 rows and 2 columns. I specified positions 1, 2, 3, 4. Here it can take 1, 2, 3, 4. It can take 1, 2, 3. Okay, that's the difference between plot, subplot and plot. Subplot and plot. Okay. Yes. Okay, so now you see the difference between plot and stem. Okay, so I want to draw in terms of subplot. Okay, I will show subplot 1, 2, 1. Plot x, y. Subplot 1, 2, 2. Plot stem x comma, so x comma y. You can see this. I divide the entire screen into one row and two columns. One row and two columns. One row and two columns. Okay, next. Okay, next. Now let's see some other commands. I actually have already tried some, so I will type those commands here. Save time. Sorry. This is a bar plot. Bar comma x comma y. For bar plot, bar comma x comma y. Bar comma x comma y. So you can go to the graphics. You can see various plotting procedures. X is the independent variable and y is the dependent variable. Okay, it's a command. Hello, any doubt? Close all, clear all means you can command, you can, when I type clear all values will be 0. Okay, clear all. You can see the workspace. Now all the variables gone. Okay, clear all means. Now let's see. Mesh grid. Okay, so I will take a editor window. I'll write this command here. So there's a mesh grid plotting. Okay, x and y are the previous case. You have seen only one independent variable. Here there are two independent variables, x and y. Okay, x and y. I defined x like this. I defined y like this. I actually defined independent variable in terms of mesh grid. Okay, mesh grid, that means with the 0.1 space between each value. That is -5, -4.9, like that here. So the 0.1 is the difference between each value of the independent variable. So I define xy region, then use g is equal to x square plus y square function. I use a contour function. I used a contour function, contour, contour, okay, contour xyg. So this is to save, print You can see that, just see this command, print hyphen DEPS graph.ep. That means it has saved as an EPS command. If you want to save it as JPG, you have to write like this, minus DJPG minus DPNG minus D. Okay, that means this is a format of the file name. Okay, here it is EPS file. So the I find out the contour value, it's because it's like circle, no, x square plus y square. It's like circle, and x square plus y square is equal to r squared. Okay, that's it's like anyway. So XYG. So this format is used to save. Okay, its name is saved as graph.eps. Minus D EPS. That means you are saving it as EPS file. If you use minus D PNG, it will save as PNG format. Okay, it will be saved as PNG format. Okay. Now let's see the second phase of this mesh grid. And I need some values here because no values are displayed, just a curve. What is the corresponding values? So when you in this graph, in this plot. So I can write like this. Control C. So please comment this. You can, if you don't want to run any code, you can just right click, comment. Otherwise, one comment symbol is here. You can use that. Okay. So now that means the percentage sign. Whenever you use a percentage sign, that line won't be executed. Okay, it will be treated as a text line. Okay, so it's a command line. It's like a comment. Okay. Now the execution start from the 7th line. Okay, now just see what's the difference between these two. Let's see. You see the difference? Contour is there, but it shows the values of G. So that is a set H short text on text step. So you can you can make your plot with lots of information. Okay, you can add lots of information your plot. Once you start using MATLAB, you can easily understand all these steps to make your graph more aesthetic and more informative. You can add more values, okay, to the plot. So when you write research papers, the plots are very much important. When you write some research papers, plots are very much important. Your labeling and your legends, labeling and your values, the values displayed inside the graph are very much important. So you can make your plot very much informative, very much informative. So by experience, you will get familiarized with all these steps, okay, that you can search in MATLAB help. And even you can plot in surface level. Okay, that is okay. Just I use a surface plot just to see a three-dimensional view surface plot. Just see that. So now we have seen the contour plot, mesh grid plot. Now we will see surface plot. You can easily search the keyword surface plot. Okay, this. So I comment. So mesh grid, I define variables. I define independent variables as a mesh grid with space I have given earlier. Then I define a variable g. It's like exponential, and it just see the surface plot of. So now it is surface plot. Okay, this is surface plot. Parallel surface plot, mesh grid, surface plot. So whenever you see a term surface plot, it will be like this. Okay, surface plot. Okay, that blue color, you can see this is a function x into e raised to x square minus y square. You can see the function here. This is the function. This is the function. The values ranging from -2 to 2 with step size of 0.2. That is a surface plot. Okay. Equations on polynomial. So actually I will wind up within 10 minutes this basics, then I will move on to fuzzy toolbox. Okay, fuzzy. That's very much important. Fuzzy and simulation, Simulink. Now you have an equation. You have to solve the roots. Let's see how. So, solving some basic algebraic equation in MATLAB. Okay, next that is. So I will comment this. So next section is solving basic algebraic equations. Okay. Basics algebraic equations. Okay, I define an equation like this. Equation is equal to x square minus 7x plus 12 equal to 0. Okay, define an equation and S is equal to solve for EQ. Here one problem is there. Can you just say the problem? Any idea? Can you say the problem here? Now it is solved. What is the difference these two steps? Simply I tried, I haven't changed any modifications. I added one more command, that is symsx. Please see this command. Symsx. Can anyone of you, can you just say the importance of that? I have written the equation x square minus 7x plus 12 equal to 0. This is the equation x square minus 7x plus 12 equal to 0. I want to use the command solve this equation. But when I write these two equations, it has shown the error. Check for missing argument or incorrect argument data type in call to function solve. But when I have added this command symsx, it executed and I got the where roots are x is equal to 3, x is equal to 4. Why? What's the problem? Anyone of you, can you just say? Yes, correct. Femin. So actually, yes, correct. Femin, correct. That means similar to when you write a code in C, you have to initialize some variables, no? So the same thing. So the system should know that this is a variable for the coming algebraic equation. That is symsx. So if I use one more variable, I should write SYMS X comma Y. That means actually you're telling the MATLAB that I am using some variables for coming algebraic solving coming algebraic equations. So yeah, initializing some variables, you can say like that, because you are familiar with C, no? So they can easily I can say like that. Okay. Now, so so you can write two equations. Okay, two equation 1 and equation 2. You can use this solve to solve two equations. That means two equations, two unknowns. Okay, can, for example, then I have to write X comma Y. Okay, can you please try EQ1, one equation, EQ2 another equation, and write solve EQ1 comma EQ2. Can you please write? Can you see? Two equations. That means two equations, two unknowns. Here only one unknown, one equations. So similarly, you can use two equations, two unknowns. Okay, x square minus 7x plus 12 is equal to 0, and otherwise equal to 5, whatever it may be. That's not a problem. Okay, equal to 5, and x square. So sorry, x plus 7y is equal to 10. X minus 3y is equal to 5. Okay, three equations, two unknowns. You can easily use this command solve. That means you should initialize like this symbolic SYMS. Okay, you have to initialize it like this. So please don't forget to use this line. Okay, solve command. Now let's even now it's 7:10. Now let's see some calculus also. Limits.
Sir,
Yes.
sorry for interrupting. Are you presenting?
Oh, I am presenting. You are not able to see that? Oh, sorry. Yeah. Oh, sorry. Yeah, just a minute. Okay, please remind me, if because I'm shifting from one window to other window. If you're not able to see the screen, plus remind me. Okay. Yeah, I have you seen this this one SYMSX? Okay, solve equations. If you want to add more than one variable, just write SYMS XYZ, whatever it may be. You can write two equations, equation 1 and equation 2. Just write solve equation 1 comma equation 2. It will give the values of X and Y. Okay, here in this case only this we are solving only one equation. Okay, now let's see some calculus, that is limit function. Okay, you can simply write help limit limit. So you get all the syntaxes of that when you write limit. Okay, you can see some examples also. If you want to know more about one command, just simply write help that command. It will display the syntaxes, and it will display a few of the examples. Okay, now let's simply see what happens when limit x minus 3 or x minus 1 limit tends to 1. Okay, tends to 1. What happens? It's not a number. Why? Limit x tends to 3, x minus 1. It is not a number because x tends to denominator will be 0. What happens when it goes to 0? We can just simply pull this command to here. Okay, so limit x tends to 0. Limit x tends to 0. It will display this value. And next, so NaN means not a number. Okay, not a number. Not a number. Okay, so you can see limit. Then differential diff command is there. Okay, diff for so we have seen the use of limit. Let's see differential. syms t. I define a new variable and f is equal to I define a function 3 into t square 3 square plus 2 into t to minus 2. I define a function in terms of t, 3t square plus 2 into t raised to minus 2. I want to differentiate it, diff of t, diff of f with respect to t. So it's very much useful when there is a long expression to find out limit or whatever it may be. These commands are very much useful. Okay. Differential integral. For example, I define a variable x already. Integral of 2x, int of 2 into x square, int of 2 into x. Integration. Okay. Integration. Now definite integral, that means, so you want to know the area of a curve. You want to know the area of a curve. Let's define a curve. X is equal to. So we discussed about limit, differential, integration. Now definite integral. Okay, definite integral means you want to know the area of a curve. That is integral with limits. X. Okay, define a curve minus 2x plus 5. Okay, define a, sorry, just a minute. Yes. Okay, then a is equal to integral of f, int of f. Give the limits, lower limit and upper limit. 1, 2. Okay, and display area. This is area, display area. Just a minute, I have to add this command. Sorry, display area, display of double with a double precision, double of a. Just a minute. For 4.333. Okay, you can also plot the curve, plot of. So plot. So I had to define t is equal to 1, 0.5, 2. Other is 0.1, 2. Then plot t, f. Oh, it's a convert into double. That's the thing. The value is converted to double. So it should be done. Data must be numeric. Okay, sorry. Some error is coming. Oh, double already converted to. Sorry. double. Anyway, let's move on to the next one, evaluating polynomials. I have to cover the next portion, that is fuzzy. P is equal to, now let's see polynomial 1, 7, 0, minus 5 and 9. So the value of this polynomial is, so 170 minus 5, 9. Okay, what is the degree of the polynomial? That means x raised to 0, x raised to 1, x raised to 2, x raised to 3, x raised to 4. Okay, x raised to 4 plus 7, x raised to 3 plus 0, x square minus 5x plus 9. Okay, so polyval, one command is there, polyval p comma 4. So when you substitute the value of this polynomial with, so next command is polyval. Okay, ortho, this command is polyval. We have seen various commands, that is integration, differentiation, then a limit, and definite integral, polynomial, then Laplace transform. Okay, let's define some variables, sys, syms, st. Okay, I just define two variables, and Laplace, some transforms. Let's go through Laplace of a, sorry, let me define this variable, just a minute. Sorry, Laplace of, it's not variable. Laplace of t square, right? Laplace of t square, Laplace of, so I have the error because I haven't defined this variable a already. Otherwise, I have to use a here. Okay. Previous error can be solved if I add a here. So I have to use all the variables here. Then this error will be solved. Laplace of a. Okay, 1 by square. Because a is already defined. Then inverse Laplace transform, I Laplace, inverse Laplace, I Laplace, 1 by x cube, inverse Laplace, t square by 2, inverse Laplace. Okay, so we can simply write this command. Then Fourier transform. Okay, f4. Okay, just f is equal to, just Fourier transform, f is equal to exp of esp of minus 2x. Simply writing one command, one function square exp of x. Define f, and just let's plot this command, es plot f comma minus 2 to 2 f is equal to exp of transform is equal to, for you are Fourier of f. You can see the Fourier function. Use inverse Fourier f4. Just add I command. So I before Fourier, Fourier minus 2 exp of ABS W. So I defined this variable W earlier. So this so there are several basic commands. So we have gone through various operations and such as metric operations, metric multiplication, and element-wise operations, transpose, concatenation, then determinant plotting. Okay, so, then basic calculus, limit, differential, integration, definite integral, polynomial, inverse Laplace transform, etc. Okay. So anyway, I think now itself time is around 7:30. Now let's move on to. So I actually would like to show a program in. I don't know how can I. So to add breakpoint, I show some. Okay. So this is a code written in an edited window, and if you want to know what happens at a particular line, you can simply add breakpoint. So I will also show to add breakpoints. That means you can add here, and when you run this code, so the program execution will be done up to that point. This process is called breakpoint. Okay. Those who are new to this MATLAB, you can add breakpoints. That means the program execution stops at this point. So now reading a audio file, this code is to reading an audio file, and the values you can see in this variable, and you can see the sampling rate. Now just one step in. Now, yeah, each value is multiplied. Next step in, moves one by one, step in. Okay. So if you type continue, the code will run completely. Okay. So you can quit debugging. It will take some time. This code is to display some modified group delay functions of an audio signal. The code is written for modified to show modified a group delay for an audio file. That means audio file is split up into different frames and use Fourier transform algorithms and display 8 values. It may take some 2 to 3 minutes, I feel. Okay, just for a while, let's okay. How many of you used this fuzzy logic toolbox? Fuzzy logic toolbox is in MATLAB. Can I just post your answers in the chat box? Fuzzy logic toolbox. Now we will go to fuzzy logic toolbox. Due to the time limitation, I think half an hour is there. Fuzzy logic toolbox. Have you ever used fuzzy logic toolbox? Anyone? Anyone of you have ever used fuzzy logic toolbox? No, no. Okay. So the answer come. This is the plot. You can see the plot. So it has taken some time now. That's why. That means you can do line by line execution in MATLAB. Line by line execution in MATLAB by adding breakpoints. I only want to remind you about this this breakpoint concept. Okay, breakpoint means you can add a particular signs like a red spot on in each line, and you can do the evaluation up to that point. Then you can simply move step by step. Otherwise, you can continue the execution for the entire code by using by clicking run command. Otherwise, continue command. Okay, so continue. Okay, now let's just get familiarized with the fuzzy logic toolbox. Okay, it's only half an hour more. Let's see fuzzy logic toolbox. So all of you just type fuzzy. Fuzzy, I think we need an introduction. You know about fuzzy. Fuzzy means okay. We'll use this. I think may not be able to cover Simulink. I think let's fuzzy. Fuzzy logic. Fuzzy logic means, for example, temperature. Just take a variable temperature. Temperature is 40 degrees. Assume there's a scale from 1 to 100. 40 degree is almost the middle of the scale. So just define this the scale into low, medium, and high. Low, medium, and high. So you can say that means for this variable you are adding membership function. That is, it is low means it is 0.2% low, 0.8% high. Okay, you cannot use percentage, and maybe 0.19. Sorry, 0.19, 0.80.
Hello, sir.
And,
We can only
yes.
see. Sorry to interrupt. We can only
Yes.
see the default MATLAB screen.
Oh, sorry. You're not able to. Just a minute. I will. Okay. I will switch to this. Now I think you can see this.
Yes, sir.
Okay. So now let's. I shall introduce the concept of fuzzy logic. Fuzzy logic. Okay. Fuzzy logic means. We'll explain once again. For example, it's case of a variable temperature. Temperature, assume there's a scale from 0 to 100. 0 to 100. 0 to 100. And just take value 45. Temperature 45. I divide the entire this domain into two regions: slow, medium, and high. So 45, almost the middle, but I say that it is around 0.15%, 0.15 and this to low, 0.8, 80% it is high, and 0.05% it is, sorry, this is medium, and this is high. So, that means I divided into 3 regions: low, medium, and high. Instead of defining a crisp set, that means one means instead of giving that means 0 or 1, instead of giving 0 or 1, that means if I give a crisp value, I have to give like this. This is medium, this is high, this is low. Low, medium, high. That means is almost in the middle, in the medium. So I just use a crisp value 1 for this. That's membership function is 1, 0 or 1. If I give fuzzy values, that means 0.15%, 0, so one, you cannot use percentage, 15% possibility to be as part of low, and 80% it is medium, and 0.5% it is high. That means I'm adding fuzziness. The first one is crisp. This is crisp. Digital as the digital logic 0 or 1. Now, instead of giving a crisp value for this temperature variable, I say that, oh, there is a 15% chance that it can be part of low, and 80% chance that it is part of medium, and just 5% is part of high. So it is a temperature. So it is pressure. It can be another variable, pressure. For example, consider a data when a control, fuzzy logic control to control the speed of a motor, speed of the motor. So input variables are temperature, and another one is pressure. Okay, temperature and pressure, and output is the speed. The fuzzy logic control. So I want to define a fuzzy logic controller, and inputs are temperature and pressure, and output is the speed of a motor, assume the speed of a motor. Temperature ranging from 0 to 100. Pressure varying from, assume it is 0 to 610 bar. Like just arbitrary the values are, okay, 0 to 100, and pressure is 0 to 10 bar. So fuzzy logic controller should take a decision. Okay, I have already given rules. If temperature is high and pressure is high, speed should be high. If temperature is low, pressure is medium, speed should be high. So I have given some rules. Okay, some rules to fuzzy logic controller. Whenever a data acquisition system, this is a DAC. This is a data acquisition system. This is a plant. This is a plant. From the plant, data acquisition system gives instantaneous values of temperature and instantaneous values of pressure. Okay, maybe 4 bar, temperature is 50 degrees centigrade, 50 or 4. So the fuzzy logic controller, okay, I have given some rules to fuzzy logic control earlier. So from this data acquisition system, these values will be fed into the fuzzy logic controller. Fuzzy logic controller should take a decision on the speed based on the rules already fed. Okay, already I have given some rules. If temperature is high, pressure is low, what should be the decision? From the previous experience, I have given some rules to the fuzzy logic controller. From the data acquisition system, all these instantaneous values will be coming to the fuzzy logic controller. It should take a decision, and it should take the appropriate speed. If it is speed high or speed low, and it should convert into a crisp value again. Okay, based on this rule. That is the concept of fuzzy logic. Fuzzy logic means you are making a crisp set into fuzzy. Crisp into fuzzy. Okay, fuzzy logic control. You can see in a washing machine, no, in LG, in most of the washing machines, you can see this fuzzy logic controller. But it depends upon the cloth material, and otherwise depends on the weight of the material. The motor, the speed will be controlled, fuzzy logic control. Okay, let's define a fuzzy logic controller by taking these two variables. Okay, what are the variables? Temperature and pressure are the two variables, and next, the speed of the motor is output variable. Okay, let's define a fuzzy logic controller. I need a particular, I will feed some rules to the fuzzy logic controller. Fuzzy logic controller should give a particular value to control, automatically control the speed of the motor based on the rules I've already fed to the system. Okay, let's define. Okay, all of you can just join with me. Let's define a design a fuzzy logic controller. Okay. You can start typing fuzzy to your command prompt. Please type fuzzy. Can you see my MATLAB window?
No, sir.
You cannot see it. Okay. So our aim is to design a fuzzy logic controller to control the speed of a motor using some rules. Okay. All of you, please join fuzzy. Just type fuzzy. Anything happened? A fuzzy logic designer. Okay, so window has come. വന്നിട്ടുണ്ടോ? എല്ലാവരും വന്നോ? എല്ലാവർക്കും വന്നോ? Okay, Siddharth. Okay, just type. Just type fuzzy. You will see one window. Window വന്നോ? FU is in command prompt. Where to type? In command. Okay. Let's see my MATLAB command window. This is command. I have already discussed. No, one command window is there. Editor window is there. So you have to type in command window. Fuzzy is there. Can you see my screen? Can you able to see my screen?
Yes, sir, we can see the screen.
Okay. Have you typed the fuzzy? FUZZY fuzzy? It is not there in your tool set. Fuzzy. Okay. So you can see this. So I am going to design a fuzzy logic controller. Fuzzy logic controller for automatically control a motor speed. Okay, two input variables. So only one input variable is here. I add it is temperature, temp. Okay. Now I am going to add one more variable. You can just watch this. If you are able to open this fuzzy toolboxes, you can also do parallel with me. Okay, yeah. Adding one more variable, input variable. Temperature, I'm going to add is pressure. Okay, pressure. Okay. Fuzzy window. Someone able to open ചെയ്യാൻ പറ്റുന്നുണ്ട്? Do you want enough time? If you also join with me, it is interesting. ഇപ്പൊ കാണുന്നുണ്ടോ? Can you able to show it? Can you able to see this? Fuzzy logic designer. Yes, yeah. Okay. So I added one variable temperature. I added another variable pressure. Okay. Temperature. If you want more variables, simply add variable. Okay. Input and output variable. And you can temperature, pressure. And I want to define the output variable. Okay. Output variable is motor speed. Okay, so I defined input variable and output variable. Two input variables, temperature and pressure, and output variable is speed. Okay, and now just save this fuzzy inference system, export to file. I'm going to add this sample file, sample1, desktop save. Okay, so you can see it's a Mamdani model. There are two models. You can see the models here. Okay, when you define, when you knew fuzzy system, Mamdani and Sugono, I designed a Mamdani model. Okay, so I saved it as sample. So you can see the name here. So I defined temperature, pressure, and speed. Now let's take temperature. Temperature, the range, just double click temperature means you can add rules to this variable, edit. Membership functions, okay, membership functions. Can you able to see this? Okay. So temperature ranges from 0 to 100, ranges 0 to 100. And this is the first membership function. Temperature low, and range. You can give the range. So I take this default range. So this is temperature 0 to 40. It is low. You can change here. Okay. The time limitations, I'm not going to do that. So parameters starting and ending. That means minus 41.6, sorry, 41.67, 41.67. It's so second is temperature is high, temperature is medium, and it is given, and temperature is high. Okay, so this is the, so I have divided 0 to 100 into three regions. 0 means the center of the low region, and 50 means the center of the medium region, and 100 is the center of the high region. Okay, so 0 to 40. So for just take the previous example. 40 was our value. So 40 means it is around 60% chance that is part of the medium, and some 40% chance it is a part of low. Okay, some 35%, remaining 5.01% or 1% chance for high. Okay, so any value, it is not like crisp. Whenever you take a variable, okay, value of one variable, temperature, we cannot simply classify that it is part of medium, or that it is part of low, or it is a part of high. No, actually we are giving membership for all the three classes. That means 80% chance that it is part of medium, and 15% chance that it is part of low, and 5% chance that it is high. For example, okay, so I define temperature. Now let's take a pressure. I taking, so I just set range from 0 to 10 bar. Okay, 0 to 10 bar. First one is temperature is low, and I just take default setting. This you can see parameters here. It's a trapezoidal transfer function, membership function. Now this is medium, and parameter, this is high. I defined temperature variables, low, medium, high. You see the membership 0 to 1. Whenever to take any value, assume it is 5 bar. 5 bar means, otherwise 4, just take 4 bar. 4 bar means it is just draw a line. So 70% chance that is part of medium, and some 25% is a part of low. Just simply you can see it's part of low. So whenever you draw a line, it will touch all the three, the low, medium, and high. One way or other way, it will touch all the membership functions. So instead of giving just crisp values, we are simply giving some membership for each membership values for each classes, each divisions. Okay, low, medium, and high. Now let's speed. Speed is low, and it is medium is high. Low, medium, and high. Okay, so I defined all the variables. This is the temperature, pressure, and speed of the variables. Now I want to add rules. You can go to edit the type, and some functions will be pop up. You can go to rules. You can add rules. These are the rules. If temperature is low, so if you're adding rules in this window. Okay, if temperature is low and pressure is low, okay, or you can easily select here. Okay, if temperature is low and or okay, and pressure is low, speed is low, just simply add rules. First rule will be add. If temperature is low and pressure is low, then speed is low. Next, if temperature is low and pressure is medium, speed is medium. Add rule. Second rule, I added second rule. Why? Because my previous experiences, I have gone through these rules. Okay, from previous experience, I have gone through these rules. All these rules I am just feeding to the controller. Okay, you should take decision. Okay, based on these rules. Next, if temperature is medium and pressure is high, and then the speed should be high. It should be medium. Okay, we should add third rule. If temperature is medium and pressure is low, then if temperature is medium and pressure is low, speed should be low. Assume speed should be low. Add rule. If temperature is high and pressure is high, speed should be high. Add rule. If temperature is high, pressure is if temperature is high and pressure is medium, speed should be high. Okay, so you can simply add all these rules. Okay, so low, medium, high. Okay, temperature has 3 divisions: low, medium, high, and pressure has 3 divisions: low, medium, high. So I have given the ranges: where should be low, where should be high, where should be medium. I have defined all this in the membership function editing time. Okay, next. Now let's see. I have defined all the rules. Otherwise, just add one more. If temperature is low, medium, high, low, medium, high, low, high. Temperature high is medium. Okay, anyway, just 3 rules are enough. Okay, now see the, now just close it I defined all the rules, close it. Just now we will take rule. I'm going to see the rules. Okay, this is the rules. So you can see the, can you see this rule window, rule window? Okay. So this is the temperature and this is the pressure, this is the speed. Now my temperature is 50. Now temperature is 50 means these are the first row. Otherwise just takes temperature of 40. I think the rule should be changed to or. Just a minute. Okay. So you can see that when temperature is 41.2 and pressure is 3.32, speed is 0.483. So I haven't defined the range of speed. Just a minute. Just a minute. Okay. Can you this rule window? So temperature is 41.2. So I got this value from this sensor, and 3.32 I got the values from sensor. Then speed should be 483. It has given the specific value 483. I change to some other. Temperature is 71.2. Pressure is some 5.6.31. Speed should be 524 RPM. Okay. If temperature is some 19.3 and pressure is some 2.08 bar, speed should be 455. Okay, just see that based on the rules, it gives some crisp value. After all this fussification, I'm doing defussification at the last stage. Okay, I'm getting a crisp value of 455. Speed should be 455, automatically controlled. When you change these values, you can change the values like this, temperature and pressure. Whenever you change temperature and pressure, based on the rules I have already given, it will do fussification and later it will supply a defussified value, crisp value, speed of 500 RPM based on the rules I have given. Okay, so like a automatic controller, fuzzy logic controller. I think you may get a chance to know about this fuzzy logic control in your curriculum, maybe in mechanical, electrical, or in electronics. I think in coming days, the fuzzy logic controller, I think in coming semesters, you may get a chance to go through all these things. And now itself is 8 o'clock. I haven't got enough time to cover all the portions. I actually planned to cover four sessions. First one is basics of MATLAB. Second one is because many people may not be new to this MATLAB. So that's why just I have given one more toolbox, fuzzy logic toolbox, to get some concept in fuzzy logic controller. But I think time was not enough to cover all these portions. If we get more chance, in future, I think I'm very glad to take cover more, to introduce more toolboxes. Numerous toolboxes in even I haven't covered live editor. Okay, similar to you might have seen in the previous classes. That is the I think yesterday or day before yesterday sessions, you might have come across the Python interface. Python interface live editor. Similarly, in MATLAB also live editors are there. You can see here, open live editor. You can home. You can these are the live editors. That means you can add command, and at the same time you can add code and your comments. When you write a comment in a simple MATLAB editor, it will show error. But here you see x is equal to y, x is equal to 20, and y is equal to 30, and x plus y. Okay, and x plus y. So I want to add some comment here. Just you can add text here. Okay, simply I write some text. When it runs, you can see that it won't show any error. Just run it. X is equal to 20, y is equal to 30. Answer is, I think you may not be able to. This is a live editor. Okay, live editor means you can simply write your comments in a code similar to Python interface. Python, you can simply write codes in the Python notebooks. You can write commands and code. Similarly, in MATLAB also you can write commands and code in the same workspace, same editor window. So you have to write this code in live editor. Okay, live editor. In home, live script or new script. If you write new script and if you write these commands, it will show error. But if you open a new live script and if you write code and the comments, the same editor window, it will execute without any errors. That is people nowadays, they use this live script. You can simply see the comments and you can go one by one. That means you can add a code at the same time. You can add some comments. Okay, that's the thing. Okay, I think let's wind up today's session. Just I covered only two things. First one is basics of MATLAB. Second one is fuzzy logic toolbox. I think if we get more chance, I'm very much interested to share other toolboxes in future. Okay, thank you. I think it's better to stop now.
Sir. Yes, sir. Yeah. So thank you all for joining, and special thanks to Rajeev sir for taking time off his schedule and joining us here today. Thank you, sir. And for those who missed the session due to network problems, a recording of the session will be uploaded in Google Classroom soon. And also, in case of any queries, please fill the feedback form, which is also going to be uploaded in the Google Classroom as well. Thank you, sir, once again, and happy learning to you all. Thank you.
Okay, thank you.